saying that time because it's imaginary. Okay, F is the name, but what's the parenthesis X denoting, signifying, notating, symbolizing, whatever you want?
Okay.
Of X. Of X. It's signifying that of. It's signifying what F is a function of, what the independent variable is, what the input is, all terminology that we use. As you guys are writing, because you're all distracted anyway, I'll take roll. Go to the team. Congratulations. Anybody in action today? So how you guys being tired? Tennis doesn't have to use it, right?
Yeah.
Cross country, their first meets always Oh, you have one early? Where's Putty? Saw Mr. Weitzel this morning. He was all here early to help you guys run or something like that. All right, here we go. So, function notation. F is the name. Parenthesis X is the of who, of what independent variable, S. So as soon as you see that, you should know what variable is present over here. All X's, right? Piecewise function. A function defined in pieces. Profound. Anyway. But the pieces are defined by, you guys already did this in your graphing calculator handbook, but you didn't do any like plugging in, you just tried to get a picture of it on your calculator. Pieces are defined by inequalities. And the inequalities are giving domains for each piece. Now domain, hold on, what's domain stand for here? What inputs or what x values are allowed, right? The possible x values. So what x values are allowed or defined by, or need to be used in this piece of the function? Okay, that's good. Can you give me like what that means? Because a lot of people do less than 0, they're like, whatever, I don't know what's that. What numbers are less than 0? Okay. So all negatives get plugged into the top piece. How about the bottom? All positives and 0, greater than or equal to 0. So, down below when it says evaluate the function when x is equal to -1, 0, and 1. We can write f of -1, f of 0, and f of 1. We're plugging it into the function f. But what do we have to ask ourselves next before we do anything else? Which piece? F is defined in pieces, so therefore we have to ask ourselves which piece will -1 have to go into? You guys would answer? And when you plug in -1, hopefully you guys are super careful. You realize you're going to be plugging into the x spot, but that x spot always needs to have parentheses. And I'm not kidding, especially if you're one of those who doesn't go anywhere or do any problem with either calculator. If you did not put in parentheses, your calculator would give you a wrong answer. Because what do I need to do with that -1 once I plug it in? Square it. And if you don't put parentheses in your calculator, it's going to say PEMDAS exponent squared the 1 times the negative. Yay! And it's going to say -1 squared is negative. You have to tell the calculator the entire expression -1 needs to be squared. Anyway, coming back. So, if we were to simplify this, what would we have? 2. You just threw it in your calculator without parentheses, it would say 0. F of 0, which piece? Bottom piece. Let me plug it in. You're being super proper. You would say, hey, it gets plugged into the x spot has parentheses, plug in the 0. Now, in context, kiddos, are the parentheses really that necessary in the second one? No. Because how would you simplify? This one, squared would be a positive 1. This one is still just 0, right? You put a 1 on the outside, 1 times 0 is 0. So it doesn't have as much meaning, or I should say, it doesn't make as much of a difference, but still it's technically correct. Final answer, you guys got it, -1, right? And then last but not least, for 1, which piece? Bottom piece, yeah, you gotta hit this positive. Plug in your 1. Which is 0, done, we want that? Done that. Okay, piecewise functions. Any questions just in general on piecewise functions from what you guys looked at last night, either in the section and or the homework? Kind of makes sense? Defined in pieces. Look out for the inequalities. Also look out for the or equal to. Okay. So, how fun was this one? Get the formula then. So fun. Every year I'm like, maybe it'll be easier this year. And every year it's still. Let's get it ready for me. And I'll do an example. And if you guys did work on it last night, you'll notice my example's a messy one. It's a nasty one. There's a lot going on. I did not pick an easy example. As you guys are writing, how many of you, just a quick thumbs up that I can see, would be like, I think I kind of get the difference quotient. I figured it out. Like 5-ish. Even then they were kind of, it's okay. The adamant head nods no. I'll take it. That means you tried. I'm trying to think of a good illustration. Give me a second. The difference quotient has a formula. You guys see the formula for the difference quotient, true?
Yeah.
Okay. What do we normally do with formulas? Give me an example of a formula. Anything. Any subject. Can be math, can be geometry. Huh? Okay, what's the formula? Okay. D equals mass divided by volume. How could you find density? For a certain scenario. Plug in mass, then divide, plug in volume, right? We could do something even more basic. We could do, not more basic. Let's do the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. What do you have to do to actually solve? Plug in a, plug in b, plug in c to all the appropriate places, and then simplify solve. True? Formulas need plugging in. How many pieces are there to this formula?
Three.
I would say 3, but how many of those 3 actually need to be plugged in for before you can proceed? 2. There are 3 ultimate pieces. You have one right here, f of x plus h. The minus, obviously, we can write. F of x, another piece. We have the division, obviously, you can write. And then we have h. H is just a variable. Now, it's a variable with tons of meaning in calculus, but we're not doing that today. So, h is just a variable. He's chilling. They tell us he can't be 0. That way it's like, okay, everything's legal. We need to plug in for f of x plus h. We need to plug in for f of x, just like you would in any formula. You have things that need to be plugged in for. So, let's take the example on the board, which is f of x equals x squared minus 4x plus 7. Okay? You have 2 options. One option is to figure out the pieces first, then plug them in. Or the second option is just put it all in, and then you're not scared of the division or the subtraction or the over h. And you'll just do it all at once. You can either simplify first, Figure out the pieces, simplify first. Figure out basically the numerator first. Then divide by h, or you can just plug it all in and simplify. I'm going to show it two different ways. So the first way, I'm going to show it all at once. Is that okay? This will probably be the more complicated way and the more efficient way at the end. If you can make it all work. But if you start skipping pieces, we're going to be in trouble. You guys have the formula, it's right there. If I was just to plug it all in, I would make one big old fraction. I would do it over h. I would put a minus. I would plug in my, what do I already plug in? I plugged in my f of x. I did my division, I did my h, I did my minus, and I plugged in my f of x. Just from what they gave me in the problem. What's the one piece that's missing? F of x plus h. And for those of you, function notation is not your forte. It's not your favorite. You make mistakes every now and then. We all do, but especially in function notation. Where does this x plus h need to get plugged in for? Every argument, right? So it's no longer f of x, and you can't think of it as just tag on and plus h. You need to think about it as you're pulling out the x and putting in the x plus h. You did have an old argument, we'll even make it a different box. You did have an old argument of x, and now you have a new argument of x plus h. So when you go to plug in, it's a little longer, because it takes a little bit more space. You could do multiple parentheses if you want to say, okay, it's time for me to plug in f of x plus h. It's the other piece to the formula, right? I have my over h, my minus, my f of x, I need my f of x plus h. Now it's time to go in and say, uh-oh, it's no longer x squared. Who is it squared? X plus h is squared. Green comes out, blue comes in. Minus 4. Green comes out, blue goes in. Pause. Check. Pause and check. If you were to do it in more of a step-by-step fashion, since you guys are all here, I'm not going to show it on the smartboard, I'm just going to show it over here. What you could do before ever plugging into the big old thing is figure out who is f of x plus h. You could just do this on its own. It's kind of a hard step. It's what probably confused most of you. You could figure out who he is. You could even simplify him. Uh-oh, don't kill a puppy. What you going to do? You're going to FOIL. Is it okay if I go quick to 2hx plus h squared? X plus h times x plus h. First, outer, inner, last. Simplify the like terms. Don't kill a seal. What do I have to do with the 4 and the negative? Distribute. You guys know what I'm referring to when I say don't kill a puppy or a seal? Okay. Another common problem is not getting that 4, well, especially that negative, into both. So it's going to be minus 4x minus 4h plus 7. Is there anything else that we could do? So instead of plugging in this form of f of x plus h, you could plug in that instead. And that's technically what I'm going to do next. Because I'm going to go ahead and come over here. And our next job will be to simplify. What will we simplify? Well, simplify all of that. You just did. Simplify that by distributing the negative and then combine my terms. So the next step, I'm just letting you know, you don't have to do it in the big fraction the whole time. You could do f of x plus h separately, then plug it into the f of x plus h spot. You're just plugging in a different form, a more simplified form. Or maybe I should say a more expanded form. I'm coming. Hold on.
So
Sorry, I just saw a hand. I didn't know who it was until you.
how can you add this 7 with f of x?
Because remember, this is, think of it as a formula again, right? F of x is technically always a formula. I don't want red. And the formula says, hey, there's a place to plug in right here if you need to. But f of x is this whole thing. F is this whole thing. Of x, x gets plugged in here. But if f of x gets changed to f of x plus h, it's still talking about f. It's still talking about the entire function. All that changes is this is different, but the pattern is the same. So the same way I leave the negative 4, I need to leave the plus 7. Because that is there, and so is the squared. Those are there regardless of what is inside the argument. Does that make sense? So that changed, but the squared, the minus 4, and the plus 7, I should say the negative 4 times, and the plus 7 remains. Yeah.
Will you give us the difference quotient formula on the x?
Oh, yeah. Just be thankful you're not doing the calculus with me. Although technically what you're doing is the hardest part of at least is where they make mistakes. They make mistakes on the pre-count. Or they make mistakes on this. We're not done. How come? All kinds of stuff, right? Meaning, who cancels? Those are done. Who else cancels? 4x. What else cancels? Wait, everything canceled that didn't have an h? That's the thing. Everything left has an h. Why is that convenient? Exactly. It's about to get a whole lot simpler. If everything left up top, if you need, I'll circle what's left, just so you can see it. Everything left up top has an h. That's always going to happen with a difference quotient that only involves polynomials. If you have a function that has trig or logs or roots or rational, yeah, it doesn't quite work the same. But with any polynomial, you're always going to have terms with an h left over. Pull out an h. You have 2x plus h minus 4 all over h. What can we now do? What can we say this whole fiddle shabam simplifies down to? You guys have any older siblings or any friends that are in calculus? You can ask them what a derivative is. In calculus, if they were using the difference quotient to solve something that we call a limit, they would only have to go one step more to have their derivative. And the one step more would be plugging in h is 0, which they could not do from the beginning because it would have been undefined. But after simplifying the difference quotient, now the impossible has become possible. You'll learn more when we do calculus at the end of chapter 12. Don't worry, we don't cover all of it. We just get a peek. But literally, in calc, they're going to be using this thing called a difference quotient. And you guys can get and understand everything up till the last step where they would plug in 0. You just don't know why. That's pretty fun. Alright, difference quotient. How many of you guys still would say, well, not still, now would say, I think I kind of know how to do it, but it might be a little tricky, but I think I can do it. Okay, good. Our rate for our improved exponential, that was good. Let's go ahead and check our answers in our evens. Let's see what questions you have on the odds. Let's see if there's anything on Calc Chat that you did not like or appreciate or understand. And then we'll keep going. So, homework number 4. Page B. Alright, we're starting on 2, 4, 10. Pencils down, away, gone, not even visible. Color pens. Here we go. Number 2, independent had to go first, then dependent. The order, yes, was important. I meant to pass out all kinds of stuff today, in case you were wondering. I got stuck in traffic for an hour and a half, so that wasn't fun. I'll do it tomorrow. I'll get one of you guys. You just go play on it. 10 is a no. Sorry, 10A is a no. B is a yes. C is a no. D is a yes. 20 is a no. Just real quick, because I'm sure a few of you didn't like number 20. Did anybody have a reason as to why it's in there? I can think two different ways of describing it, yeah. It's a straight line. It's a vertical line. Well, what if you put a vertical line on top of a vertical line? Is it going to hit more than one point? Yeah, it is a vertical line. We have issues. Fails the vertical line test. Another way of thinking about it, vertical line. How many x's are there, guys?
One.
It's actually a solid line. Okay. How many points are on that? Sorry. How many y's go with that x? Does it have more than one? Yes, it fails. Remember, each x can only have one y. This one has infinitely many y's. Okay, this is not. Okay. Which one using no?
For number 10,
Yeah.
what was B, C?
A was no. Then yes, yes. No, sorry. No, yes, no, yes. There we go. A was no, B was yes, C was no, D was yes. Right? 36. This was piecewise function, like we saw at the very end of it, yeah? Plug in, plug in. They showed it two different ways. One's a table, one's function notation, either way. 1 and 2 should have been plugged into the top piece because of the inequality. 3, 4, and 5 should have been plugged into the bottom piece. As you guys look at it, how would the graph look? What would be going on the left of 3? Yeah, downwards parabola shifted up 9. What's going to go on to the right of 3 and including 3?
A line.
A line. Where's the hole going to be, on the top piece or the bottom piece? Where's the hole going to be? Where it goes all the way up to but not including a point. When piecewises come together, if they're a function, we can't have points in two spots. So if we have the downwards parabola shifted up 9, right? He's coming in from this direction towards 3. So we plug in 3 at 0, right? X minus 3, that has a 1, 2, 3. Would have an intercept, but it's not over here. It's way over here by 3. 3 minus 3 is 0. That's here, going up. So they're both coming in towards 3. Who gets the point and who doesn't?
Equal to. Second one.
Good. The second one gets the point because, what does it have in the inequality? An equal to. And this one's going to have what? The whole. Except, hold on. Plug in 3 to the top and to the bottom. Where are they both supposed to be if they were allowed to be at 3?
0.
Oh, so they end up meeting. So the hole is on top of the solid point, so really, there is no hole in this one. That was a trick question. But in other piecewise functions, if you had something like this, let's say it was 2 lines and they didn't meet up, why would they not both be allowed to have a solid circle? Yeah, which is why one inequality has to be not or equal to and one has to be or equal to. Otherwise, I guess that could be a hole too and it would still be a function because it wouldn't fail. It would just be missing an x. But you can't have 2 filled at the same time or else that would fail the vertical line test, yeah? That's what I was asking. Okay, number 56. You have a function. What are you doing with it? Domain? You guys saw the denominator? Did you factor the denominator?
Yeah.
Did you say neither 0 was allowed to be in the domain? So what's an easier way of writing besides the sentence, the domain is all real numbers, x except x equals 0 and 2? Yeah. D colon x not equal to 0, comma 2. Does that make sense? Both ways work. Long story short, not 0, not 2, everything else. 66 was a party. I heard some of you guys talking about that one. Didn't you have like a rectangular box or something in 66?
Oh, you need to plug that in.
They gave you a box. They talked about volume. What did you have to go back to geometry to remember? Yeah. The volume of a box is the area of the base, length times width times the height. They gave you different dimensions for what the length and the width and the height could be, so you plugged in for x's and y's, got an expression. But they also gave you a clue. If we're trying to graph volume, we have to get volume as a function of x. This is actually very similar, or at least fairly similar to the word problem that we did in notes having to do with the cylinder. You had to go back to geometry. You had to figure out how it relates with x's and y's. I guess that one was r's and h's. You had to take your clue and say, uh-oh, I need to solve for y because I need this guy only as a function of x, and do some substitution. Domain was a little hard because this was implied in context of the real world problem. I don't know why those are straight up and down, but that's okay. Domain was implied in the context of the problem. I'll talk about that soon. But the long story short, I think, is that you were trying to find the maximum volume, right? Correct answer is right. Maximum volume, right?
Right.
So the maximum volume, how do you find the max of a nasty function? We graph it. We say, hey, we know how to find the max from our graphing calculator handbook. But then once we get that max, the max actually ends up representing the x is going to be just fine, but the y is going to be a v value when you finally do find the max on the graph. Trouble is, doesn't like you being in the picture. You have to go ahead and solve for y. So let's pause. It seems like not a lot of you guys got very far in this problem. Let's keep checking. We'll come back as to why he was funky. 68 was also a word problem, right? Let me freeze it for just 1 second and let you guys see. Waiting time is to get answers. That is true, especially to evens that you could not have checked online. But remember, it is not the time to frantically write down everything that you might possibly need for the problem, because that's something you need to make the connections for. Frantically writing it down is just as bad as copying from CalChat, and just as detrimental. I'm pulling up the book so we can look at 66 and 68. But let me go and get some confirmation from you. What questions do you guys want to see from homework, odds or evens? Go. If you don't say 66 or 68, then I won't do them. Okay, 66. Anything else?
68.
Okay, 68. Thanks for letting me know. For being real. What else, Melanie? 49. 77. Jack?
81.
81. Start to lose track. 49, 77, 81. We had 66 and 68 in there. Anything else? Okay. Alright, let's go ahead and check these out. Where's my book? Okay, it's missing. Not helpful. Let me try again. Sorry, Mrs. Christensen gave me a new computer because mine was literally dying. I just wore it and stick around. So I'm trying to figure out what's going on. While that comes up. Let me pull up CalChat too. Because the odds, the ones that you guys gave, you were able to look there and it didn't work, right? Or it didn't help as much as you wanted it to. So we're in section 4. As I do this, kiddos, because as you can tell, things are taking a little bit of time with the new computer. It hasn't brought it up before. Go ahead and keep your colored pen in your homework. Once you open up your notes, you just get started. Table of contents you can do. The beginning of notes you can do. And in just a second, we'll shift right back to homework questions. You guys can be all set up for the day. Thank you, thank you. 49? I think I should be pretty close to finishing this one. I'm going to scroll and let you guys get one more page. You don't need to skip any lines. Yeah, you don't need to skip any lines. About 30 more seconds. I saw a few of you still writing when I turned around. Alright, I have 49, 77, and 81 ready to go, and then 66 and 88. Alright, here you guys go. One more page for you to get down. Because you didn't need to skip any lines, just keep it going. Right? Yeah. You don't even need to really skip lines in between the examples. It shouldn't take a lot of work as far as showing work. One more minute. To get what you can, we'll come back to it all together. This was number 49. The problem they were asking us was find the domain of the function. Okay. We talked about in our notes domain problems. Tell me, like, what are some of the ways that domain can get messed up, hence restricted, hence have any answer other than all real numbers? Square root, or?
If the x is in the denominator.
Good, if I have some sort of x expression in the denominator. So square root, or if I have an expression in the denominator. Problem. Not even problem. The problem, the exercise number 49. Are there any problems in the function f of x? No denominators, no square roots if you want to think a little bit further ahead, no logarithms, no trig with asymptotes. If there are no problems, then, if they don't say otherwise, what do we assume the domain is? All real numbers. So you might have been a little confused as to why the answer was what it was, but the long story short of it was, The domain is all real numbers since there are no problems in the domain. No square roots, no denominators, and in the future, no logarithms or trig. We say, booyah, all real numbers every time. The next odd that you guys had was number 77 and 81, the difference quotient. Let's just go see how CalcChat did it, because 77, guys, how similar does this look to the one I did at the beginning of class today? Very similar, but there is one difference. This looks super similar. What's different over here? There's not an X, there's a 2. But does that really change a lot? If we look back over here at the board, what would have changed? What would have changed in this example if they had asked for f of 2 plus h instead of x plus h?
The constant would just change.
The x would just change to a constant, right? So all of the x's would have been a 2. Maybe this would have actually made it even a little easier because there wouldn't have been as many variables. And then we would have simplified beyond this and done like, oh, hey, you know what? I can do even more than I could with the x's because there are more numbers now. So maybe you could simplify a little bit more. There just won't be x's, and the x spot will be a 2 in the sense of the x plus h. And what's going to change when we go to plug in? Well, we're not plugging in for f of x anymore. What would we be plugging in for? F of... Yeah, so we wouldn't just plug in f of x, we would plug in f of 2. Right? So we'd end up with 4 minus 8 plus 7. Oh, look, it's purple. Blue and red. Anyway, all that changes, not the process, not the formula, all that changes is instead of an x being in all those places, a 2 is going to be in all those places, which means we'll be able to actually simplify and get numbers. But at the end of the day, we're still trying to cancel out an h with the denominator to have a nice little expression, probably with numbers and h's at the end. Okay? Let's see if you guys can get that. Let's peek at CalcChat, though, and see if we can kind of follow along with what they did and whether or not they made any crazy jumps. What do you guys see? I see f of x. Hey, I see they actually showed really good work, huh? That's what I would have showed. They plugged in, they FOILed, they simplified, they got their f of 2, and what did they do with this piece and this piece? Where were they supposed to put it? In their formula, right? So take f of 2 plus h. Wow. Okay, did they skip a step in here somewhere? They did it right about here. They decided to do the whole numerator first, and they said this guy minus that guy is this. They skipped some steps. They didn't show it quite as clearly. I would have just plugged in h squared plus 3h plus 3 minus 3, which would have simplified to be factor out the h, cancel. They don't show that factoring out and canceling, but that's what's going on. And then you're down to your final answer. So follow that CalcChat after you try it on your own. See if that makes more sense. But what's weird about number 81? He was weird. I totally agree. Why is he funkier?
G.
Well, okay, there's a G, but what else? These are fractions. If you guys don't mind, I'm going to show you CalcChat real fast. Just let's see if they showed their work pretty well. Did they show plugging in g of x to the piece? Yes. Did they show plugging in g of 3? Kind of. They didn't show what it was before 1 night. What was it before 1 night? 1 over 3 squared. Good. So they plugged in g of x where it's supposed to go. They plugged in the 3, but they just simplified, so 1 over 3 squared is 1 over 9. They wrote the division, they wrote the x, they wrote the minus 3. Oh dear, how'd they go from there to there? CalcChat does jumps. But some of you can simplify complex fractions easily, and some of you can't. Let me help just a little bit. Plug in your g of x to the g of x spot in the formula. They're plugging it in all at once. Plug in the g of 3. Plug in 3. Plug in 3. 1 over 3 squared is 1 9. You have your division, you have your x minus 3. You're going to see me do the following to simplify complex fractions all year. If you decide to take calc, it'll be in your summer packet this summer for next year. If there is ever a fraction in a fraction a numerator, a fraction in a denominator, look at the denominators of the This is the word I still have never been able to come up with. The entrenched, the inscribed, the innermost. The little baby denominators inside the fraction. Compile them. I see an x squared and I see 9. Multiply the top and the bottom by both of those little denominators. Think common denominator. If I was to try to get a common denominator, I'd do x squared over x squared. I'd do 9 over 9. I'd put it all together and have to think about how to divide by a fraction is multiplied by a reciprocal. So much easier just to multiply top and bottom by the combination of the two denominators. What happens when I distribute that guy over there? You get 9x squared over x squared. Some of you are right. It's going to simplify quite nicely. What happens when I distribute him there? 9x squared over 9. What happens down here? 9x cubed minus 27x squared. Can I simplify anything up here? And you always will be able to when simplifying complex fractions. You get 9 minus x squared. If you're like, I think they had it factored. Okay, they probably did. Maybe they didn't multiply the 9x squared. Simplifying complex fractions, yes, it's something from Algebra 1, Algebra 2, but it's hard, so we're going to review it. That's how I would have done it. There are many different ways. That's the way that I would have done. And that's probably mental math, what they did here, because they went that jump awfully quickly. But once again, remember, you don't have to make these jumps on your own. They went ahead and actually you can factor the top and simplify with the bottom, but that's all in Calc Chat. Kiddos, I said earlier, we're going to go ahead and look at 66 and 68 tomorrow. I have them ready. But the long story short of it is, you guys did get to see the solutions in class today. You did get to see the solutions in class today, so maybe look over those solutions. It's in the video online. And see if you can maybe come back tomorrow with a bit more informed questions of how did they do this? Why did they choose to do this? Why did they do this in their graphing calculator? Let's use those solutions to help us out a little bit. So last night you saw the word problems, you got stuff. Tonight look at the solutions, now that you got them, they're on the video, and keep going. As you can tell, 1.5, see I didn't even write it on the board. It's not through tomorrow, there's no way we got through it. This homework section usually takes a lot of time to go over the questions. I'm going to go ahead, though, and make the homework due on Thursday, meaning we're only taking one day on this homework. We're only taking one day on section 1.5. So tomorrow we're going to cover 1.5 in its entirety. It should be a little bit faster, and we'll see how fast we can go. But in order to do that, I do need you guys to be a bit independent tonight. Go back to these two word problems. If you need to, go on the video on the website and pause, look at the solution key and be like, what am I missing? Why did I not get it myself? And then 1.5 tomorrow. If you guys notice, it doesn't look all that bad, right? No word problems. Maybe something a little bit at the bottom or at the end. But actually a lot of it is, that's a calculus thing, a lot of it's review. Even and odd has to do with symmetry. Interval notation has to do with inequalities. Zeros, well, we've done that already also. So 1.5 should go fast. Please, please, please look at 56, 68 again tonight. Bye, guys. Thanks for hanging in there.
My heels hurt.
Happy nutrition.